know there's a key online for this. I thought I'd make a video of me working through these problems and kind of talking myself through. Definitely going to put this guy to use right here, and I'll probably throw a few of these guys on just so I have some room to draw. So anyway, let's get going on this. So a normal distribution, that's our normal curve, has a standard deviation of 10. So I'm going to start by drawing a curve. This is our mean. Call it x bar if you will, or mu, it doesn't matter, whichever one at this point. And one standard deviation is about where the curve starts to change. Two standard deviations is the same distance out, and I'm going to do the same thing on the negative side. So if this is a standardized curve and this is standardized, then our mean falls at 0 standard deviations away from the norm. This would be 1 standard deviation, 2 standard deviations, and -1 and -2. And so the value in this particular problem between these standard deviations is 10. So that means to go from no standard deviations to the first standard deviation, if we were talking about scores, which we are, then somebody who scored 10 points higher than the mean would be 1 standard deviation away from the mean. 2 standard deviations, another 10 points. And the same thing goes backwards. 10 points less, 20 points less. Oops, I don't want to write 20 there. Sometimes it's hard to say something and write something else. Anyway, so the curve is the key on this. So what I want to do then is I want to look at seeing if I can apply and just the curve to get a z-score. So a score that is 20 points above the mean is going to have a z-score. That's what these guys are right here. These are the z-scores. So 20 points above the mean is going to have a z-score of 2. And that's all it's looking for there. A score that is 10 points below the mean, starting at the mean, I'm going down 10 points, that's going to have a z-score of -1. 15 points above the mean, that's going to put us between 1 and 2, which would give us a z-score, of 1.5 between the 1 and the 2. And 30 points below the mean, I don't even have that on my table here or on my graph, but that was going to put us way back out over here at -3. And so that would be -3. And that's all we're looking for, is to identify what that means as far as a z-score. And the z-score is how many standard deviations above or below the mean a score is. Okay, next problem. I'm going to assume that you guys have read these. So what this is talking about is an intelligence test and a couple things in here. We've got a mean of 35 and a standard deviation of 6. And we have a normal distribution. So we've got our normal curve again. So if I were to draw this, I'm not going to draw this one like this guy up here, but if I did, then this value of 0 would be at 35, and it would be 6 points, or 6 points to change from one standard deviation to the next. So what number represents the 65th percentile? Okay, so our formula for this is x, the score, minus the mean. In this case, that's 35, divided by the standard deviation, equals z, or the number of standard deviations away from the mean. But we can use our table to switch back and forth between z and some percentile. So in this case, we're starting at 65% here, and we've got 35 here and 6 here. But I need to take this 35% and turn that into a z. So I'm sorry, 65%. So here's how I'm going to do that. I'm going to look on my table. The percentiles are in the body of the table. And then I'm going to look for 65% as close as I can get. It's kind of up towards the top of the back side here, the positive z-score side. And I have 6480 or 6517. It turns out this one's the closer to 65. I want that one, even though it's over. So that's going to be 0.39 is the z-score for that. So 65 percentile puts your z-score at 0.39. I'm going to write that over here, and I'm going to get my equation written here. X minus 35 over 6. So I'm putting in the mean and the standard deviation. And now I'm simply going to multiply times 6, both sides. It's just solving a simple equation now. And I'm going to add 35. And my calculator's hiding here somewhere. It's got serious. There we go. Reflection. So 0.39 times 6, add 35. So I'm adding 35 to bring this over here. And that gives me a score of 37.34. So what that means is, for somebody to get a score high enough on this test to be in the 65th percentile, they've got to score about 37 points on this test. And that's 65% of the people scored, or the test takers would have scored below that. So the 90th percentile works the same way. I'm going to take the table and I'm going to look for 90. It's going to be on the positive side. Get as close to 90 as I can. I'm getting close. That would be this guy right here, this 0.8997. That's as close as I can get. And that appears to be a 1.28. So I'm cutting this one a little bit quicker, 1.28. The setup is exactly the same, x minus 35 over 6. So I'm going to multiply 6 on both sides. 1.28 times 6 plus the 35 means that to be in the 90th percentile, somebody would have had to score about a 43. So x equals 42.68. We'll go ahead and write that in as the score. This one's for this guy here. All right, the probability of getting a score between 28 and 38. I need a little extra room to work here, so I'm going to use a sticky pad. If I curve this, if I draw this curve, for this scenario, I've got 35 here at the mean, 6 points as a standard deviation, 38 is only 3 points away, so that's going to be maybe about here, and I'm just guessing. I don't think I'm guessing poorly, I'm just kind of estimating. And 28 is more than 6 points away, so if I was -1 standard deviation, I'd be a little bit less than that, maybe about here. So what we're looking for is the space between these. And what I'm going to have to do on that is I'm going to have to standardize for this and that. So I have the scores, these are the x values, but I have to do it twice. So I'm going to say 28 minus the mean of 35 divided by 6 equals, and that's going to give me a z-score. Let's see. Now be careful with this. You can do an order of operations error with this. So I'm going to take the 28 minus the 35, and then I like to hit enter so I don't have to put any parentheses in there, and then I'm going to divide by the 6. So I get a -1.6. I'd round that to 7. And I'm going to turn that into a percentile. So this is our z. So turning that to a percentile, negative 1.6. I'm sorry, I wrote that down wrong. This should be a 1.17. My bad. Negative 1.17 is about 12%, 0.1210. So that means about 12% falls below that z-score here for the 28. Now I'm going to do the same for the 38. So 38 minus 35, that's 3 divided by 6, which would be 0.5. And I'm going to go to the other side of the table and I'm going to look for 0.5. I hope my head math was correct. And I get 0.6915 because it's 0.50. Did I write that down right? I think so. Yeah. So what that means is that about 70% or 69%-ish, a little bit more, falls below this line. But that includes this 12%. So how do I get the shaded part between? That's going to be 0.6915 minus 0.1210. Or 57.05%. I'm going to leave that as a decimal, 0.5705. All right, D is exactly the same, it just has some different numbers. Both of them are above the mean. And again, I would sketch that just because I want to make sure I understand what's going on. The mean is 35 here. 41, let's see, is exactly 6 points above. So that's going to be at 1 standard deviation. And 44 is 3 points above that, which is going to be a little bit more. And so what we're looking for is this area between those two guys. So 41 minus 35, I'll start with the lower one, divided by 6. Well, let's see, that is 6 divided by 6, gives me a z-score of 1. And if I go to the table, the z-score of 1 is 0.8413. So that means that 0.8413, or about 84%, falls below that. And now I'm going to do the same thing with the 44. The score minus the mean, divided by the standard deviation. Now, if I'm not right, that's 9, so that's going to give me 9 divided by 6 is 1.5 standard deviations above the mean. And that guy is going to be right here at 0.9332. So this is about 93% falls below the 44. Now what falls between them? Well, that's going to be the 0.9332 minus the 0.8413, which is 0.0919. Cool. I hope that's so far so good. I hope that made sense. I totally encourage you to draw it out. If you draw it, even if you draw it poorly, it's okay. It kind of helps us to understand what's going on. All right, for the next problem, we're talking about the SAT, and we have a mean. This is mu, but that's the mean. We talked about that the other day. That's that funky MEM MEUE thing. So that's a population mean and a population standard deviation. And it wants the minimum score to be in the top 15%. So they're giving me a percent. I'm going to have to work that backwards to a z-score, but here's what that looks like. The mean is 500. And I want the top 15%, so I'm just going to kind of guess here and say this is 15%. The problem with this, getting the z-score on this, is our table never works on the upper part of the curve. It always works on the lower part. So the question you kind of have to ask yourself is what's below this? And that's 85%, and that's the number I need to use to get the z right there. So I'm going to set this up. I'm going to say what's the score? It's asking for the score minus the mean divided by the standard deviation equals, and I've got to find this z with using the 85%. Excuse me. So 85%, looking for as close as I can get. Let's see, 8508 is here, 8485. This one's closer to 85%, so I'm going to use that. And I've got 1.04 is my z-score. And on this, I'm going to multiply both sides by 100 to get rid of that denominator. And so what I get is x minus 500 equals 104, and I add 500 to get my final score. X equals 604. That is the score you'd have to get on this SAT to be in the top 15% given that information. All right, B, I went through, I think, in both classes. But this one, I really like this question and I really hate this question. They give us the answer, or they give us the thing that we need for the answer. They're actually giving us the scores. So they're saying the middle 80%. So what that means is I've got 80% in the middle, and remember this is a symmetric curve, so that means that each tail is going to be equal at 10%. Now, you can use these and standardize both spots with the 500 and the 100, but I think there's an easier way. And how I changed this question, by the way, to answer the question the way it's asked, you literally would just take the 628 minus the 372, and I won't deny that there are some questions that are that easy sometimes on tests and problem sets and stuff like that. But I thought that this was too easy, so what I changed this, I asked you guys to find me the z-score for each of these. And you can do that using our standardizing formula by going 372 minus the mean, 500, divided by 100, and then do that again for the 628. But I think that's the hard way, and I'd rather you do it not the easy way because it's easy, but the easy way because it's conceptual, okay? So here's what I'm going to say. You know the bottom tail is 10% here if you've drawn this out and thought about what it is that they're saying, the middle 80%. So I'm going to go to my table and I'm just going to go directly to finding 10%. Be careful, a lot of people go to 1% accidentally. So I'm looking for as close as I can get to 10%. I'm getting close. This looks like it right here. And that is a z-score of negative 1.28. And that should be pretty much what you get solving that. Now, how much of the data falls below the top 10%? Well, that's the 80% plus a 10%. So I'm going to look at the positive side, and there's a shortcut to this. Hopefully you'll see it here in just a minute. And I'm looking for 90%. So, oh, I've already circled it. Look at that. I've used it already. 1.28 is 90% of the data falls below that. Now, why are these numbers the same? Well, it's because the curve is symmetric. The 10% on top has the same z-score that's positive as the 10% on the bottom where it's negative. So the values are the same. So if you recognize that, you really only ever have to find one to get them both if you have the same amount in each tail. Cool. All right. So 4 and 5 are really just translating into z from percent to z-score or z-score into percent. So the trick here for 4a though is saying that it's the highest 30%. So if you go looking for 30%, you're going to find it on the negative side, and that's probably not going to give you the answer you want. So again, I'm going to kind of just draw a little curve here. Make sure. And so 50% on each side of the mean, so the top 30% might be something like this. And again, this is just a sketch. It's not perfect by any stretch, and I don't intend it to be. But remember, the table only works on the less than side. So what I really need to look for on the table to find the z-score for the top 30% is I need to look for the bottom 70%. 1 minus the 30%. All right. Ooh, there's pretty close to 70% right there. And that's pretty close too, but neither one of them is exact by any stretch. A lot of times they aren't. The closest one is the one I want. That's this guy right here. It's probably not the end of the world if you chose that. So my z-score is 0.52. And that's all this is looking for. Okay, that is the answer for 4a. 4b is saying the lowest 40%. Well, that's the table's really good at that because that's how the table works. It's always looking for the less than value. So this one I don't really need to draw probably, but if I did, it would look like this. That is really a terrible looking curve. If this is the mean, the lower 40% is probably something like this. And I can go straight to the table on that because I don't need to change that. So the lower 40%, oh, that's pretty close, heading in the right direction. Definitely this guy right here is the closest, and that is a negative 0.25. All right. Number 5. This one is a little bit different. It's asking us to evaluate this z-score, but it's also asking us to evaluate it in terms of the mean. So the mean is in the middle, and what you have to recognize is that on each side of this is 50% of the data. It's balanced. So I'm looking for 1.17. That's going to be somewhere over, oh, maybe even a little bit farther over if I'm drawing it correctly. Perhaps maybe something like about here. So z equals 1.17. And the question's asking us for the area between the mean and the z-score. So that's literally, in this case, looking for this area right here. Now, I know that this side of that mean has 50% of the data. What I don't know is how much of the data falls less than the 1.17, so I go to table A, and I go to 1.1, and then over to 7, and that's 0.8790, so almost 88%. So then this value, this answer, is going to be the 0.8790 minus the part that we don't have shaded, which is 50%, which is going to give me what, a 0.379 or 3790. Oh, trolley's here. And I'm going to do the same thing with this guy right here. Negative 1.37. I've got my mean here. Remember, 50% falls below that. I don't really need to find a z-score for that. I know that. Negative 1.37 is going to be out back here. It's the z. And I'm looking for this area right here. So negative 1.37. Negative 1.37, 0.0853. So what am I going to do here? I'm going to take the high minus the low. So this is going to be 0.5, the median. I'm sorry, the mean, minus 0.0853. And that's going to give me an area of, let's see, what is that? 0.4147, I think, if my head math is correct. If it's not, I'm sure somebody will correct me. That's it for page 1. I'll do a separate video for page 2. Look for that one.